Okay, let's get started. Tonight's about memory, initializers, constructors, and then inheritance, depending upon how far we get. And tonight's lecture is going to start with lecture number 2 of the PowerPoint. So under here, I'm in the Objective-C section here, and then in the course materials on the bottom under PowerPoint lectures. Number 2 is, I believe, going to be memory. And then 3 and 4, initializers and inheritance. So this is kind of the game plan for this evening. And so less playing around on the computer, more, well, we'll do it a little bit, but more looking at basic concepts. So this is lecture number 2. I'm going to open it up in preview, which is where I had it. Oops, that is number 3. We don't want number 3, so we want number 2 definitely. And let me make this so it says content only on it. Make this a little bit bigger. Actually, let's make this real big. Any questions before we begin, though? Nope. All right, moving right ahead. All right, so, yes?
Yeah, when you add the GUI controls.
The GUI controls, yes.
Yeah. Other than the drag and drop, can you go and add those properties like changing the IDs or text?
Programmatically?
Yeah.
Yes.
I mean, even in the UI itself.
In the UI, you mean in the XIB file, the interface builder, or do you mean in the source code?
The properties and attributes and like where you set the background and everything.
Yeah. You can set all of that by the source code inside of the source code.
There itself can be add IDs and the name and description. Other than like you select and drag and drop and then you do name to the GUI control, I mean text box or anything.
You can set it through the GUI. You can set it through the properties box. You can also set it through the source code.
I didn't get aware of the property box.
Oh, let's bring it. Well, I might have a problem bringing up Xcode right now because I'm currently updating it. But let's see what happens. Nope, it's not going to let me. We have to wait for a few minutes. Remind me of that question when in about.
I could not figure it out. So.
Remind me in 12 minutes or 10 minutes. We'll take a look. Are you also in the iOS? Are you also? Yeah. Okay, so I'll definitely answer it sometime tonight then for you. All right. So if you haven't guessed, there's another Xcode update out that I've been updating. So actually, you guys can probably update right now if you think. It came out on January 28th, I believe, or 29th, which would have been between this class and the last class we had, actually. However, you don't necessarily have to upgrade it unless you have a newer iOS device, and which I do, which is what the problem is. So, not a problem, is which situations. All right, let's talk about memory. Back to the memory concept. So this is all talking about that ARC, automatic reference counting button that we keep pressing. And so now I'm going to give you the background in terms of why we're pressing it and what we're doing with memory and how memory is being managed by Objective-C. So it's memory management, and what we're looking at is a semi-automatic system. If it were automatic, we wouldn't have to do anything at all. Semi-automatic is that ARC button when we press to select auto-reference counting. So I'm going to talk about what those are actually. Programmer, if we're not going to use the semi-automatic, not going to use the button, we have to, and we still actually have to explicitly, and we will always have to explicitly declare objects or allocate memory for objects. So we reference them, we can declare them through instantiation, through instances that we're creating, and we're always using alloc on that. So that's the semi part. That never went away. What went away was the release and the retain. If we don't want to bother with the second half of it, once we create the object, if we don't want to manage it in terms of getting rid of it, and then we press that ARC button. So I'm going to talk about that in a few minutes as well. So we explicitly use the word alloc as we've seen so far. So we say new memory object, new person, or excuse me, person space alloc, and then we initialize. So I'm going to talk about initializers tonight as well. Or we can indirectly use convenience constructors. What does that mean? It means that there's a method that's written inside of the object that gets called by the initializer. So we can initialize it with memory, and so we can run them both together if we want. But there are two separate steps. allocating it and initializing it, as we've seen. And there's never need to deallocate anymore, actually. So allocation, what does that mean? Allocation happens when the class method alloc is called. And alloc is a built-in method of the class that we're running, and it's there automatically. We can't override or overload it, but it is there. And the message alloc is sent to the class of the requesting object, and the alloc is inherited from NSObject. So when we inherit from NSObject, that's where we're getting that alloc from. Every alloc creates a new instance, which equals a new object. And so this is the syntax we've been looking at so far. We go hello world space alloc. And then we usually stick this inside of an init in it. So the class creates an object with all the zeros to it and returns a pointer to the object. So alloc is sort of like saying new, for the most part, if you're familiar with other object-oriented languages. It does nothing more than allocate the memory. So here's another way of doing it, where we have hello world, which is the name of the object. A pointer to the object, which we've seen so far, equals hello world space alloc, which is equivalent in some languages to saying hello world p is equal to hello world, new hello world. So the syntax is a little bit different because we have the method, Objective-C method calling technique that's a little different. So the pointer p now points to a new instance, and so now we send messages to the instance through p, which is referred to as the reference. So that's why this is called a reference variable, because it's referencing a piece of memory that was created that we stamped a label on and called it hello world. So reference counters keep track of anyone who is still referencing it. That's a reference. So we know that's a reference because we declared it with a reference pointer. So things that we don't use a pointer with aren't references. If we say integer I with no pointer, I is equal to something, that's not part of the memory management system. Only this referenced pointer is part of the memory management system where we have alloc involved. So that's why we can use old variables from the old days. We can go integer I, float f, double d, all these variables that we can create that don't use pointers, they're not part of this entire system at all. They're just managed by the runtime environment. So that's our pointer. So reference counter is keeping count of these references here. This is going to create 1. This is a 1 reference counter because we have one item, this piece of memory here, that's associated with it. So every instance has a so-called reference counter associated with it. So it counts how many references are retained by the object. So the counter is 1 after the allocation. And it does not count how many references exist to the object. So I'm going to have some examples in the lecture. It's either 1 or 0. It's either being referenced or it's not being referenced. It would be too much overhead, and why do we have to worry about it if multiple things are referencing it? It doesn't really matter, does it? All we have to know is that one thing, at least one thing is referencing it, and then we know it's being used. We have the words retain and release that we can use, and I'm going to show you some code today actually that has a retain and release in it, so you can kind of sort of see how it's being used with a dealloc. It's some legacy older code. I pulled it out of my archives so we can take a look at it. But normally now if we're going to use the ARC button, we're not going to use retain and release. But sending a retain message to the object increases the reference counter by 1 and makes sure it's 1. So we don't really care what it is as long as it's greater than 0. Sending a release decreases the reference counter by 1, so it makes it 0. Takes the reference away. Release means let it go, essentially. What do you mean by let it go? Let the garbage collector pick it up. It doesn't go instantly. It goes the next time the sweeper comes through and looks at the memory locations and says, what can be cleaned up? When is that going to happen? Probably when you need to allocate more memory. So there's a possibility that something might be allocated, might be released, but may not actually leave memory because it doesn't have to. So we don't have to worry about that. So the reference counter equals the retain counter. When the reference counter reaches 0, the object is automatically deallocated by the garbage collector. And the programmer does not deallocate. Deallocation happens automatically. All we do is retain or release. Retain means keep it. Release means get rid of it. Why are we going to retain it? Well, maybe we're going to use it again. We created it in this method and we used it here, but we're going to use it again. So we don't want to have to recreate it. We'll just use it. So we retain it and then we can keep it. Otherwise, we're going to release it and let it go. So rules for memory management. So here we have the method that does an alloc or a retain must also do a release eventually, because if we retain it, we're going to keep it forever. So we're going to have to release it. And if we allocate it, we're going to have to release it if we're doing this semi-automatic method. So it must maintain a balance between the alloc or the retain and the release. So think of the retain and the alloc sort of on the same side of the fence, and then release is the exact opposite of it, which is sort of like a delete for the most part. So if the method does an alloc and returns a pointer to the created object, then the method must do an auto release instead of a release, which is where we have that auto release and the auto release pool, which are kind of some separate techniques that I'm going to get into in a few minutes here. That kind of shows you the difference. Calling the code can do a retain release, but this is not a must actually. We don't have to do a retain and a release. We just create an auto release, which means let it go when it's done. So let's revisit that auto-release pool if we haven't seen this yet. I think we have seen it probably on day 1 or 2 of the class. For the auto-release to work, that should say auto, not auto. That's a typo on the slide. The programmer must create an auto-release pool using this here. So we have ns auto-release pool, and then we have a pointer we're going to call it pool, and then auto-release pool alloc and initialize. What does this do? It just creates an instance of the object pool. Is the name of the instance, and it's of the type ns auto release pool. Then cook is used when the auto release pool is created automatically, and the programmer does not need to do it. Its auto release happens automatically when you release the pool. So to release the pool of all the objects in it, you do a pool release. So originally we had alloc, retain, release, alloc, retain, release, and then we have auto release pool. And then the third generation around we have ARC, automatic reference counting. Some of them actually have, they're all supported still. You can still do a retain and a release, just turn off the automatic reference counting. You can still do the automatic release pool. If you're going to do that, you're going to do it with, well, you're going to do it without the reference counting. ARC, you're going to do it on its own. Or you're going to do the ARC technique, which is just going to be alloc, 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 alloc. Forget about all of the releasing and all of the retaining. We don't have to worry about that anymore. And there's no pool. So, which is where most people are right now, especially in the beginning. They're going to essentially worry about just releasing when they have to release, and when they're going to allocate it, or if they're working with legacy code, and they're just going to basically worry about allocating at this point if you select automatic reference counting. So I have an example. Let's see. This is still going. So in a few minutes, I'll show you in 2 minutes, but I think it's going to take longer than 2 minutes. I'll show you the example that I have that has all of the different options. Well, actually, it has the legacy option. We've seen this one from the beginning. So, and I'm going to switch gears a little bit, talk about convenience constructors and constructors in general and initializers. Just so that I can, save some time before I can bring up Xcode here. So let me hold the thought about memory. We'll see it live in a few minutes. Let's talk about convenience constructors. That actually kind of fits into the same concept. And they call it a convenience because we can allocate the memory inside of the initializer when we construct it. And the initializer is what's going to initialize the data. Well, we can create another method that says just initialize the object with something, and that's referred to as a convenience constructor versus a constructor, which is normally an automatic kind of mechanism. So the class method that allocates and initializes an object, programming either doing an alloc or an init. Here's an example here. If we had a student object, and we wanted to create what was called a convenience constructor, then we would take and make a student with name, and we'd take on a parameter name and a GPA, and then we'd create an ID new instance. What is this new instance? And notice over here, this is a class method and not a instance method. So we're actually creating a class level method that we're running, which is nothing more than creating a new student with a name. And this one looks like a GPA too. And what are we doing here? We're going self alloc. So we're going to run alloc to create the new instance, and its student name, GPA, return this new instance, and then auto release it because we're not going to use, let's say for example, we're not going to use the ARC button. So the concept is, and I'll show you what initial, this is kind of a rare thing people like to do because they don't like to type alloc all the time. So they'll create this method, which is a class method because of that plus. It's not inside of your method that you're creating inside of your class. It's inside of your instance. Your instance isn't running it. Instead, it's a function you're going to run that's going to create a new object. But it saves you because when you run it, you don't have to say all the allocs and the inits and everything. You just create a new instance. And it makes it a little bit more user-friendly. So essentially, the method sends alloc to self, which is a student object in here, because we have self space alloc, which is what it is. It's going to create a new instance, which is kind of very similar to the new student kind of terminology. And the method auto releases the instance because it returns a pointer to the that is the created instance to the created instance. And an essential example is an existing initializer. Uses an existing initializer up here. No, it doesn't use one, but it should use one. It's using the NS object initializer that already exists. Could use something else or initialize the student data directly. So let's see how it works. So this is how it works. Calling the convenience constructor, we're going to say ID student. Remember ID? I think I talked about that. It's a generic pointer to an object. ID student. Student is equal to student with name Johnny and GPA 3.8. We wrote this convenience constructor so we didn't have to go alloc and new. What do? We just took the syntax and changed it around. That's why they call it a convenience constructor. So what is it going to, well, let's go back up, take a look at the body of that constructor. Here it is right here. We could have put this in main. There's no reason why we didn't, outside of the fact that we didn't want to. So instead here's the init here, here's the initializer here. I'm going to talk about initializers in a few minutes as well. We're running the initializer to set the name and the GPA on this new instance that we're creating. We could have stuck this line of code out here instead, put it right here, and that would have been the same thing. But people do that because some people will write the classes and the methods, and then other people will write the interface to it. And then this is easier. You don't have to allocate or initialize anything. So a lot of these times you'll see code libraries and things. You just use it and not have to use alloc with it, not have to use init with it, not have to initialize anything. Because basically what you're doing is running a convenience constructor that was created. And the convenience part of it is that you don't have to worry about the memory allocation. It does it for you. And in there, you can do the release and the retain and everything else that needs to be done. So sometimes you'll see that. Were they going to write them yourself? Probably could, if you wanted to simplify your life a little bit. Because the concept is create the objects once and use them over and over again. So it might be a nice idea. So in this particular case, the message is sent to the student class object here, because this is a student object that we're creating, and returns to a pointer, and the pointer is assigned to stud up here, which is the ID that we created. And the calling code is neither an alloc nor an init. And then the auto release must be in place, because this isn't doing any release either. This is doing an auto release. So we have to put this in an auto release pool, and then it will auto release. Basically, when you put auto release on there and you have an auto release pool, it basically says, well, when you're ready, take this one too. Take this one. It's like you're adding it to the pool for the auto release. So it basically doesn't retain it, it releases it, but it releases it automatically with everything else that is part of that same grouping that you're going to put into the pool, which is why they call it a pool. Yeah?
I'm not completely clear on how we read that. On how we read that return statement.
The return statement is returning this new instance that's being created. Here we have ID in.
Oh, got it. Yep. Okay.
And it's auto-releasing it because we're going to use an auto-release pool with this example.
So is auto-release a keyword?
It is a keyword.
Okay.
It means add it. If I go back up to this example up here, if we create this pool here, and at the end of the code we pull release, we release the pool, but in the meantime we add to the auto release. the pool is nothing more than a collection of objects that we're going to all release at the same time when they need to be released. Instead of doing them all individually, we just auto-release, 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 instead of having to alloc return, retain, alloc release. So it's basically a way of automating the collection of items to release. You can do it all in one shot. Now, if we had ARC turned on, automatic reference counting turned on, we could take this out and just return new instance from this. We don't have to run the auto release. In fact, you'll never see the auto release if you're using automatic reference counting. But if you're looking at legacy code, you're looking at something that's using a pool, you're going to get, and I'll show you an example in a few minutes, you're going to see this auto release. Or a release. It doesn't necessarily have to be an auto release. So the convenience constructor does nothing more than take all that stuff, put it inside of a method, call the method, it makes the object for you, and it does all the details of everything you need. Do we really need a convenience constructor now that we have automatic reference counting? Not used quite as much. Instead, we still use initializers. I'm going to talk about the initializer in a few minutes as well. For those people who are familiar with other languages, the initializer is sort of like the constructor. Like in Java, constructor, or C++ constructors. That's the initializer for Objective-C. Why didn't I just call it a constructor? Not sure. But it doesn't follow the same rules if you're familiar with other languages. Constructors normally have the same, it's a method by the same name as the class name. I believe that's the same case. There's no return type in C++. I don't believe there's one in Java either. In Objective-C, all it has to do is have the words init in the name, and then it turns into an initializer. So it could be initializer with something, initializer that doesn't do something, initializer blank, 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 blank. As long as the word init is in there, all of a sudden it's an initializer. And then, I'm going to go over this with a couple more examples in a few minutes. Then it's treated as if it were a constructor, but it's never called automatically. The only thing that's called automatic is init. So you can have an init, and that init would run like a constructor. So when you go %alloc and you put that inside of init, you're running the constructor. So it's not implicit, it's explicit invocation of that constructor. It's not really a constructor, I call it an initializer. But you can run as many initializers as you want. You can create as many as you want, run whichever one you want. Send a different number of parameters. Same concept as a constructor. So instead in Objective-C they call these convenience constructors because they're not really constructors. They're created to make the convenience of automating. They're not an initializer either because this one's calling an initializer. You can make it so it doesn't call an initializer. You can make it so that it just copies this information to the data members automatically. And that would be a good way of doing it as well. So let's take a look then. See if my Xcode is, oh, look at that, I'm updated. Very good, now I can bring up Xcode. I have an example here, if I can find it, that is going to go through an old way of doing something. App book, here it is. Let's see. Well, then she'll just run the project, and I'm going to show you. This is a kind of an interesting project. Oops. Uninstall device support. I just updated my Xcode, so it's going to... hopefully the interface is not completely different than it was last time I looked at it. Every time I update Xcode, something new happens with it. I updated this time because I want to support my iPad. For those people who have a device, if you brought it today, we're going to set it up automatically for you as well. If you have a device and you're sitting here, send me an email message with... You did? Okay, good. Because as soon as we get to the first kind of break, we're going to... which is probably not going to be until after the class. Trying to end with a little bit of time so we can set some devices up. I need to send you an invitation through the Apple developer account for the university. So, and this is going to run. Hopefully this is going to connect in a few minutes. Installing files. Hopefully it won't ask me to reboot the computer. Unfortunately, I probably should have done this before the class started. But let's see. The internet speed wasn't so good. Anyway, so the code I'm going to show you is going to look at, there's no automatic reference counting being used at all, and there's no pool being used. It's actually kind of interesting because it's just a basic release, allocate, release, and you'll kind of see the examples of it. This code is not available to you because I purposely made my other examples use the automatic reference counting, which is the more current way of doing it. So, there we go. Start using Xcode. That's nice. Yep, here we go. Alright, so this is, let's see if I can find, let's see, examples here. Let's see. Hold on one second. Let me go into the quiz game here. Validate. Here we go. And just showing this to you as an example, what would normally happen if you weren't using it. You're going to see something like this in the code. It's going to say dealloc. Or sometimes if you download source code examples, you need to try to run them and you have automatic reference counting put into place, you'll get error messages if you have anything that has a release on it. So this is a little quiz actually, and in the quiz itself, it is creating questions and buttons and things and using it with an interface. And at the beginning, it allocates instances, and here's one here. At the end of a method, instead of saying, instead of returning, this is a return call actually. Instead of returning auto release, it's returning release, which means return the object and then release it, which running a release on it on the return. At the end of this here, excuse me, at the end of the if statement that's being run actually. So it's doing something here. It's creating this is a good example. It's creating a string here, adding a message to the string, printing out the score, and then at the end releasing the string. This is what you don't have to do anymore. If you have auto release pool, if you have automatic reference counting selected, you'll never see this statement in your code anymore. In fact, we haven't seen the statement at all. This is a piece of legacy older code. But you see here, finish statement release, score update release. Every time you use it, here's another example. Here's another string that was created. This one was called the score update, string alloc, and initialize with the format here, and add something to it. Now release it, which means we're done using it. We're going to use it for something, and then we're going to be done using it. So release it, and then you're wondering, well, where is that memory being stored? Well, it's there. It's just this here was updated. This we don't need the string anymore. We just created the string temporarily to give us a value to print to the screen, and it's basically our score. And then we added score update. We to this method here, and then we added this value to this piece of data member here, the text that's associated with the score. And the score up at the top is up here somewhere. The score, here it is, the score. It's a UI label that we're using. So for a label, we created a string, some information we wanted to print to the label. We put it on the label, then we released the object. So now if you have automatic reference counting selected, you never see any release of those objects. Instead, what you see is basically these lines are being taken out. So here's what happens. You find some legacy code. It's a nice example. You want to run it, and you get a bunch of error messages, and immediately you figure out, well, I created my project with automatic reference counting. And the first thing usually people notice, and this is a dead giveaway, is if the code has anything associated with a dealloc method. It's sort of like the destructor. So for those of you who are familiar with C++, we don't have this in Java, but we have this in C++. We have constructors, copy constructors, and deconstructors. Well, the deconstructor, this is the dealloc, which is the equivalent to it. But we don't have to worry about any of this if we're not if we're using automatic reference counting. So, long story short, when you see those examples and you, oh, this is a great example, so show them how to do this, right? And you load it up in there, it doesn't work. Think about the memory. Just be familiar. There was life before automatic reference counting, and we had to allocate, we had to deallocate. And the deallocation is probably what's throwing the project off. Now, the other option you have is not to turn on automatic reference counting. You can turn it on and off programmatically inside of Xcode for each project that you make. However, it's probably not a bad idea to go the automatic route because things happen to be going that way. Pretty soon it'll evolve, hopefully, to the point where we won't even have to allocate anymore, which, you know, hopefully that will be the case. And it'll be more like Java for the most part. But it's not quite there yet. But I'm just letting you, giving you some information on that. Not to spend too much time on it because you'll probably never use it. So let's talk about initializers because those you will use. So section 3 or lecture 3 is on the concept of initializers, and we have some initializers. I want to kind of go through the concept first, and then I'll show you some source code examples with it. And these are big ones that you can download and look at. I don't have anything with, actually it's all over the internet. You can find a ton of examples with dealloc methods in it, and release and retain all over it. Initializer, as I mentioned before, it has the same, has the name initializer. So the initializer name should begin with init. So it starts out init, init. Returns the initialized object or self to it. So that's what init with first name, init with last name and first name, init with, and which is how people normally are starting to label things. Calls the initializer of the superclass. So it'll automatically call init, plain init. And then, let's see, we'll propagate up the chain of inheritance until the family of inits from NS object is being called. Actually, just like the constructor firing order, if you're familiar with C++, happens in the same order. So first thing we get is an NS object. Next thing we get is whatever class was first in the inheritance line. And then next we get whatever's class is next. And then actually the dealloc works the exact opposite order, which is the same as C++ as well. So it's very similar. Actually, both languages are sort of similar in concept. So initializer uses the value returned by the superclass init. Let's take a look at one in a few minutes, make more sense out of it. It must consider and correctly handle constructor errors, hopefully. So we know about the method syntax, I hope, and we know that the definition precedes the plus or the minus. We'll return and a return type here. So we have this as a method for a class, excuse me, for a method, instance method, not a class method. And the return type as a CCast, so it's float, which is going to be the return type. Which is kind of interesting because this is a CCast. If you think about it, casting data types. So if the method has no parameter definitions, the call consists only of the method itself. This is a little review of the syntax for you, by the way, because we actually haven't gone over this in that much detail yet. So if a method has no parameters, okay, so each method is represented by each parameter is separated by this colon, not the commas, followed by the parameter type as a CCast. So example here, colon, integer part 1, which is going to be the first parameter. So it's the same, the method parameter syntax is the same as the method declaration. So it uses the same type of CCast. The only thing you don't get are the minus signs. So the access parameter is the only thing that happens that's different at the beginning of the method. So before each one of the colon you can put a label, as we've seen so far, and the labels become part of the method name. And you compare, let's say for example, the two definitions below. We have these two are the same. We have minus sign, which means it's an instance method, minus sign instance method. Float, CCast to the data type float. And then we have sum, A, B, C. So we put names in here. So we have sum, and then we go of A, this is the red part, of A and B and C, optional. If we put it in there, it makes it a little bit more self-explanatory when we run the method. Sometimes you see, initializing with float and double and something or other. And you type that in, and this and that, so it matches the method call. And then it makes it a little bit easier to remember that A comes before B, that comes before C. But in this particular case, probably a little senseless. Here's an example. So the definition is on the left, the example of the call is on the right, and here's our first one. This is what we just looked at in the last example. Sum A, colon A, space, colon B, space, colon C. So we have object sum, and then we have 1, 2, 3, assuming to be A, B, and C. And these are floats, so we're going to go 1.1, 2.2, 3.3, just to give it some values. And then return A plus B plus C, which is our method call. What is it? It just sums up A, B, and C. Or the one underneath it, which is twice as much code, it looks like. But some people like it because it's a little bit more self-explanatory. Sum of A and B and C. And then when we call it, we go sum of A and B and C. So we actually include, instead of sum, we renamed it now sum of A, and then we have and B. So we don't go in here. We're not going, which is kind of inconsistent, I think. But we're not going sum, sum, sum. We're just leaving it blank. And here we're going sum and B and C because we have and B and C. So essentially, what we've done is rename the method call so the parameter is expecting this name that's following the semicolon instead of just using the semicolon. So if you want to think of it that way, you can use blank plus semicolon, or you can use the name plus a semicolon. Either way, the semicolon has to be there. So, two methods do the same thing, but the second one reads much easier. Contrary to disagree with that one, because I think this one actually reads better to me. But some people like this here because they know that this is A, B, and C. And actually, you know, maybe if you put the code down and then like 2 months later picked it up and looked at it, you are not going to know which order the A, B, and C's are going to be in, maybe. I don't know. So read the details and explanations of the lecture notes. That's what I'm giving you. So that was our little review on method calls, because we're going to need that when we look at the initializers. So initializers with arguments. Here's an example of the Hello World initializer. I'm going to show you another one with some code that we're going to download and take a look at, and you'll see it run. So this one's called init with number, colon n, and value v. So we have, again, two parameters, and they're named. So it's common to see the initializers with named parameters like this, because then we know which one we're calling. So number is equal to n, value is equal to v, and then return self. We know it's an initializer because it starts out with init, which means when we run it and we create the new instance of the object, instead of putting init after the new object space alloc and then put that inside of another method called to init, we run init with number and value. And it performs the same thing, except for this time it initializes it with a number and a value instead of just nothing. The big difference in the return self at the end, here we have return self, which is at the end, and then return type of ID that is called dynamic. Well, we know that this right here is called a dynamic typing. We do that because we don't know what kind of object we're going to create. It's more flexible that way. Same as void in C. So it's very similar to the void. It doesn't really return any types, just the object that's being returned. Now we write this, and this is how we would call the initializer. So we have ID HW for hello world, the instance that we're going to create. And that's going to be equal to hello world alloc, and then we have init with number 3 and value 3.7. So instead of just saying init, we put a few more items, and we put 2 parameters in there. So you'll see those a lot. In fact, all of the built-in methods have a couple of different, like you use an object for something that you're going to use in some project that you're going to create. You can initialize it with a string. You can initialize it with a float, with a double, or something. So it creates polymorphic behavior, but at the same time it creates different initialization options. So initializer is much better, but still not totally correct. We can actually improve on this one by calling superinit, which is what we're going to do next. So here's kind of the basic format you're going to see over and over again. As soon as you see it a couple times, you'll go, oh wow, that's like everybody uses the same thing. And it's kind of like, the de facto standard. You want to call the superinit, superinit, superinit. It's how you get all of the initializers to trigger. So it's kind of like in C++ calling from an inherited class, calling a previous class a constructor and specifying which constructor you want. You can do the same thing here. So you can specify which initializer you want from the superclass. from the base. So the call to alloc returns a new object. So you can send init by sending the inherited init to the parent class, which is what we're doing. Initializer should continue only if the init succeeds. So we have a little check here, which says if not self, if we don't get a super init out of this, then return nil, no object here. If we get a super init out of it, then continue, and self is going to be number, and then the value is going to be v. Very similar to C++ actually. That's in place because we're using a pointer to the object. We're using the arrow symbol instead of the dot notation, which is the same thing for a reference, because all objects are references in Objective-C, whether we make them that or not. So we're not using any pointers here, but they're still references. So the whole call becomes more complicated, but it's explained, yeah. Well, sure, I just explained it too. So don't forget about those little messages on the bottom. And it returns self, the same as the previous one. The only difference about this one is it's calling the super init instead. If we wanted to, we can call the super init with a named parameters as well. So we can put value 1, value 2 in there. And that's basically how we would send back the information to super, to the main object that was above us. Here, when I haven't looked at inheritance yet, we're going to see that with a couple of inheritance examples. Here's a new class, and we have 2 constructors in this class. We know we have 2 constructors, 2 initializers. I'm sorry, now I'm using the keyword instructor. So we have the interface student, and this is an example I'm going to show you live in a few minutes. Then we have NSString name, float GPA, and so we have one init and an init student here. Then we have NSName, name, and float GPA. We're going to run. It's pretty straightforward. And then if we implement it, because that was the interface, and when we implement it, this is going to look the same every time we do it. This is the same initializer we just looked at a few minutes ago. And then we have this other one that's going to look the same. So we just stuff this in here. You see it's kind of repeated over and over again. Stuff it in there. It just makes it so that it's going to explicitly call the super init. We're going to call it anyway, but at least here it can return a message if it didn't work correctly. When we call it implicitly without specifying that, we don't necessarily get to have that same level of error control that comes out of it. So why do I want that? Well, it might help us figure out what's going on with our memory. If we can't create the object, we might be running out of memory or something. And if we were managing memory ourselves, we could have more control over it. So let's take a look. So the example that we're going to look at, I believe, is in the in the classes section. So this one is called classes, and it is out here in the course materials subfolder of object-oriented programming and Objective-C. And this one is called OC class, how to create class objects. So this is the one I'm going to be looking at in a few minutes here. Download that one and zip it, and we get this one here. It says OC classes. And we've gone over, let me just take a look here. I had this bookmarked. I believe it is in example 3, but let me just check. It is in example 3. Okay. So what we want to do is go to example number 3. There's 3 subfolders in this. When you download the code, you want to go into example number 3. And click on it. We've actually gone over 1 and 2 already, so you may already have it downloaded. So let me make this real estate a little bit better here. There we go. All right, so and we got a bunch of error messages. That's great. Get rid of this one. All right, so in here we have 3. We have a person, and this is a little bit review as well. Just if I say this over and over again, probably will. Some of it might sink in. So we know how to create a person object, and then in main we're going to make some instances of the person object. So in here, this example here is well documented, so you can go ahead and read through some of the comments in it. We have person, who is being inherited from NS object, and person has 2 private data members, name and age. And then see, here's the constructor down here on the bottom. It says init with name and age. And there's no init, there's no plain init initializer, because it's kind of assumed that we're just going to, you know, if we could call it, no problem. It's just going to call supers init if we do that. And we're not calling supers, well, we will in a few minutes, but in the header, this is the .h file where we're implementing the interface. We're not specifying anything about super, we're just basically creating our method footprint. So in the implementation of this in the .m file, you can see this is heavily documented because it's meant for teaching an example here. Self is going to be, this is a different way of doing it. I separated it out. Instead of putting it all together saying if self is equal to self, you know, return nil out of that, or not self. I basically made it a little bit easier. So the method call itself is going to create self. So self is equal to super init. So call the super init first, and then check self. So it's done in 2 steps instead of 1 in the previous example. You can do it like this, it's no problem. This one's also doing a retain and a release because it's a very old example, and it's twofold. It's showing you the garbage collection mechanism as well. So if superconstructor returns a success, continue the initialization. So if self means if we have it, then everything's inside of if self, not return self. And then return self is going to have a problem if self is just equal to super and it doesn't return. So it's going to automatically trigger an error message for us if we're out of memory or something. And this example is calling it a constructor here. It's saying that the method init is a method provided by NSObject that provides a default constructor. So for all intents and purposes, the initializer and the constructor is sort of the same concept. So if self, release and retain our memory management mechanisms here that we're going to use. Once the count is 0, the memory is going to be released. So n retain, n name release. Well, n, if we could take a look at our variables up here, string name is the name that we're using. N is coming in from the parameter line. So it's going to be a short-term parameter.
We don't have to know, write specifically at private.
Ah, don't have to do that. If you don't do that, it's assumed to be private. This example is heavily documented with everything you could possibly imagine in here. You're right. Good point. I forgot to mention that. So n retain, m release, and then m name is going to be equal to n. And some people are like, well, why don't we release it? Because we can garbage collect the old value. And then after we release it, we can reassign it. So we're reusing name, but name is a member of this object. So we're releasing, but then we're assigning it. So it's kind of like it's going to reduce the reference count, and it's going to increase the reference count. So do we really need to put n release in there? Not really. Probably could get away with taking it out. May end up with a memory, or depending upon how much memory we have available. If we don't release it, we're going to create another piece of memory out there, and that's going to hold the name that's going to be equal to something. And then the age is simply an integer and not a pointer, so it's passed by a value, and there is no release. So if you think back up here, go back up to here and take a look here. Integer age, I'm sorry, I meant to say age. Integer age, there's no retain, there's no release on age because we're not using this pointer. So it's only when we use pointers do we have to retain or release, and we're not allocating it either. So if we come up and take a look at the code here, age is going to be equal to A, that's basically all we have to do. And to retain it, it's going to basically make sure it doesn't go away because we're taking it in on the parameter line, retain it. Release name, have name equal to n, and then at the end we can auto-release everything. Our setters and getters, which are kind of interesting, they're overriding. So if you create setters and getters, it's going to overwrite. We didn't property and synthesize, so we have to write setters and getters. This is before property and synthesize, so it's kind of an older example. And instead of going set name, get name, we're just using name. which follows the same syntax of the setters and getters. So name, string name, return name, integer age, return age. And then we have this other method here, speak. Speak's just going to print out a name. It's going to say, have our object speak is going to say its name and its age. It's going to print it to the screen. So it's pretty simple kind of an example. And if I go back to the .h, that's all we have are these three methods, name, age, and speak. So in main, we are going to look at some memory allocation as well. So alloc reserves the memory space for the object. NS autorelease pool is an automatic garbage collection mechanism. So this example is actually using the automatic. Let's just take those messages off. There we go. So NS autorelease pool is going to be equal to autorelease pool alloc init, which means initialize this autorelease pool, and then set the name to equal this NS string, and then we see string with string, which is going to be a method called to set the string with a string. And then person barb here, we're going to make a new instance of this object that we just created, person alloc, and then we're running our initializer, init with name and age, 500. So, and then this is showing you that you can use the legacy C code inside of your Objective-C code if you'd like. And so what we've got here is our printf being used on purpose. In fact, up here I've imported stdio.h. Not C++, but C. We don't have to use include, but we could actually put include instead of import. It would mean the same thing and would work the same way. If, for example, you're stuck and you want to use a C function or a C method, actually it would be a function that existed, like printf as an example, or scanf. Not highly recommended, but if you want to, you can use it. It's supported. So Objective-C is backward compatible to C, but you don't want to write C code unless you have a purpose for doing it. So this, by the way, is very non-standard. So we're not going to. We would probably use a more updated Objective-C way of using it. But it's just to show you that you can actually take it, convert it to a C-compatible string, which is what this is doing. It's running a method UTF-8 string, which makes it compatible so we can send it to the printf function and print it out to the screen. And so we're going to run barb name, barb age, barb speak, and then barb release at the end. And what are we releasing? We're releasing the barb object down here. Now we made an auto-release pool. We could stick an auto-release pool down here on the bottom, which is why these error messages are, these not really errors, they're warning messages that are coming out, because it wants me to put in an auto-release pool on the bottom. But in this example, it should run just fine actually. Not your best example for many reasons, but build successful, that's good. So it prints out name, age, and then the speak method on the bottom. Yes, unused variable pool. So we created the pool, but we didn't use it, so I can actually just comment it out, actually. And then what do we have here? Using string with a literal is redundant. Yeah, it is, actually. We're assigning it a string literal that's a string, so it's sort of redundant. No harm, no foul. So. Alright, so if you haven't looked at it already, if we haven't looked at it in example number 1 of the class code, let's just go through and see what's here. I'm going to go through some of these examples because a lot of people learn by example, so it kind of shows you. This was Hello World, by the way, so we've already done this one. And I just want to make sure that we've done number 2 as well, because I want to hit inheritance next. I believe we have done number 2 as well. Number 2 is the differences between the property and the synthesize. Yes, we had one class that was simple car that used the regular old initialization mechanism, and then simple car 2 uses property and synthesize. And so you can see the differences here with the property, the make, model, and the VIN, compared to the .h, where we've got strings and a number for make, model, and VIN. No property, no synthesize. So if you're interested in reviewing that, that would be example number 2. Example number 3 shows us the initializers. So we're ready to progress onto more examples and inheritance. So what we want to do now is go to WSC code number 2. So which is going to be programming practice number 2. So we've done programming practice number 1. It had hello world in it, had a bunch of other little things that we looked at. So we're progressing now to programming practice number 2. For those of you who are following along or want to follow along. I'm going to unzip this fresh so I know which one it is actually. Okay, it is code 2. In code 2, let's see. I believe it's example number 3 I want again, but let me just check here. No, this is where we were just a few minutes ago. Hold on a second. I've got the wrong one. I think we want number 3 now. Let's try number 3. Code number 2 is what we were just looking at a few minutes ago. I thought that I had it here, actually. Let's see. Inheritance, yes. Okay, so code 3 is the one we wanted. So inheritance number 1 and inheritance number 2. I believe we want to work 2 and go backwards, but let me just verify that. Let's look at number 1 actually. Number 1 has a slight problem in it. There's a directory inside of a directory. So when you go into inheritance number 1, this is the way I remembered it actually. Click on the subfolder. Oh no, it doesn't work. Okay, this one, maybe I fixed it. I could have fixed it. I have a version of the zip file that it's got it in the wrong direction as well. I've got it inside. So depending upon when you downloaded it, it looks like I fixed it. So inheritance example number 1, let's take a look at inheritance. So we saw person, we just looked at person a few minutes ago. This is the same person as we saw before, except for person here has only got age in it. We're going to set the name here. Oh yeah, I mixed and matched here. So what do we have in here? This is actually to show you something else again. The original person had NS string name inside of the interface, opening and closing brackets as a private data member of this particular class. So what I did is I left age in here and I pulled out name. And name now is going to be a property. So just review the concept here. If I go over to the person.m file, I see synthesize property, but I don't see synthesize anything having to do with age. So once we've declared age, we're stuck with age. So I have set age and get age. But I don't have to do that. If I go back to person here, I see I have 2 member functions, set age and get age, but nothing for name. But I'm going to be able to use name the same way. So this is again another illustration of how to use the property and the synthesize in place of setters and getters. Trying to drill that point in a little bit more. And here are the 2 method calls that are implemented for set age and get age. In fact, I could have just called it age, but if I have an age and an age, so probably better to say age and then get age as an example, or excuse me, set age and then age to get age. But in any case, get age is returning age, and set age is going to take age and have it equal to x, and then print, and we're going to use printf again, it looks like here. Age is something. Print out age. Very simple code. So what I'm going to do now, this is the base class, and we know it's a base class because it's going colon ns object. So we're inheriting from object here. So now if I go into employee, we'll take a look here. Now I see the colon here, and I see person. So naturally I can say, well, this is going to obviously lead to some inheritance example because I've got employee colon person. Now I'm going to add integer ID to it. And I'm also going to property, and I'm going to do the same thing as before. I don't have to do it this way. Normally you're going to use one technique or the other. Probably going to use property and synthesize these days. But now I have job title. But each employee is also a person. So I have the age and the name inside of the employee, even though I don't actually have, I have person, but person is inherited from, excuse me, I have employee. Employee is inherited from person. Person has a name and an age inside of it. Employee now has an ID. So the way inheritance works is you get everything that's from the previous object is automatically a member of the current object. You make instances of the current object and you don't reinvent the wheel. You just inherit everything back from the base, which is what we're doing with NS object actually with the alloc and the init. Those are all methods that are coming from NS object. Alright, and so when we make the class, in fact here we'll make another class here. So I've got person in here and I've got employee. Well, let's make another one. Let's call this one staff or something. So I'm going to come up here to, I've clicked on the folder, the main folder of the project, or actually I can click on down here, but I have them up here at this level. File, new, this is how we're going to create a new object. I'm going to go to File. And I'm going to probably mess myself up for later, but I'm going to click on the OSX over down here and click on the Coca. Well, do I want to click on Coca or do I want to click on another one? Let's see. This is where I say I'm going to mess up myself for later. I'll just put up Coca here. Class object, Objective-C class, next. And then it should tell me, it should populate down here. It should put person down here. It's probably alphabeticalized. Let's see. Here's person on the bottom. So I can subclass of person. Or I could create a subclass of NS object and rename it. So here I'm gonna put in here janitor. Janitor. How do you spell janitor? Oh, that's pretty good. You know, actually, teacher, I can spell that. There we go. Because this is a DOS-based application, I'm not going to get the XIB interface, but if I wanted to, I can do that as well. So I'm going to click on Next. And what I'm doing is doing the same thing as how we populated employee, but now we're going to see another one. So now I have teacher. So now I have implementation of teacher on the M file. What I really want to do is look at the H file. I have the same thing as before. So teacher's coming from person. If I wanted to, I could actually do this instead and go employee, because this isn't a teacher and an employee. And then I would have to say, well, what's wrong with this? It doesn't match this one here. Implementation teacher. Did I misspell employee?
No, you have to import employee.
Yep, you're right. You're right. And then I would import. Well, actually, you know what? I'll just change the same line because there we go. Employee.h. There we go. So now I inherited now from employee instead of from person, because teacher is really an employee. So. And then what am I going to get? Well, I'm going to get everything from person and everything from employee. And now I'm going to have teacher. Well, let's see, what do I have in here worth keeping? Well, an ID, so a name and an age. So I could, you know, maybe add in here teacher, I don't know, integer something, TID or something. Add another variable in here, and then I could use that, set it from the teacher. So when I create a new instance of the teacher object, I'm going to get an employee and I'm also going to get a person. If I create an employee object, I'm not going to get a teacher because that's above it in the hierarchy. If I create a person, I'm not going to get anything outside of a person. So the higher you go up in the hierarchy, the more objects you're actually creating when you make that new instance, which is the same concept you get in inheritance with other languages. So let's take a look at the employee class. So this one extends person, and we have a set ID and a grow sum. So it's going to grow, it's going to age. And the set ID is going to take on y as an integer value to set the ID, which is an ID. Job title. And the implementation is just as you might imagine, setting the ID to y. This is the ID that's part of the employee. And it's printing out the ID, essentially, after it sets. And then grow sum is going to take 10 times self get age. And we're actually running, which is kind of interesting, the get age, and you're wondering, well, where is get age here? And you're looking at this going, where's get age? Well, get age is actually down here in person get age. So we're running get age down here. Whoops. But self is, although we are in the employee object, we are also a person. And person has get age in it. So we can run methods inside of inherited objects that are using the same methods as the Imagine it's all inside of the same object. So we can flip back and forth and use it. So normally what I end up seeing is when students start using inheritance is they start reinventing. And then you're basically overwriting it. Putting in another age. You're declaring another data member of age inside of employee. And then you're really defeating the purpose of inheritance, because what you really want to do is use what you already have and extend it and build it to enhance it, to specialize it. So in other languages they call it specialization. So I guess the same concept applies here. So if I take a look at main, where's main? Here's main. And what is main going to do? Well, we're going to create two instances. We got an employee and person. Person object 1 is a person alloc, and it's nothing too special. We didn't write any initializers in this. I actually have an assignment that I used to give out that had you write initializers for this, which is why this is bare bone. Employee object 2, employee alloc, and initializer. You can probably easily write an initializer for it. All you do is create something that says init with name and age, and init with name, age, and ID, and then send age and name, name and age back to person, and then in employee initialize the ID to something. And if that were the case, then we would probably use a class variable for that instead of an instance, and then have some sort of rolling student ID. Yes? Oh, let me pause this then for 1 second. We have announcements today.